thread priorities. You might have already learned about process priorities. Let me tell you, threads also have priorities. JVM selects a runnable thread with the highest priority to run. All Java threads have a priority in the range 1 to 10. The top priority being 10 and the lowest being 1. Normal or default priority is 5. This is assigned implicitly when you do not specify a priority for a thread. Thread class has defined 3 final variables which represent minimum, maximum, and normal priorities. Now let's look at an example. In this example, I have the class thread priority which extends the class thread, as you see here at line 2. In the public void run method, the method which is overridden from the class thread, I am printing the current thread name and its priority. As you see here. Here the method current thread is a static method which returns the reference of the current thread object. Further, in the main method at line 17, 18 and 19, I am creating 3 thread objects and setting them with a priority of 3, 5 and 1. At line 20, I am starting the threads. In this example, you will notice that thread T2 would complete first, and then thread T3 will be the last to finish. For better understanding, you may extend the loop at line 4. I recommend you to work out this example from Java Virtual Guru before proceeding further. When a new Java thread is created, it has the same priority as the thread which creates it. Thread priority can be changed by the setPriority method, as we have already seen in the previous example. Here are a couple of more statements for your reference. Now in this case, when we start T1, it starts with a priority of 6, that is normal priority plus 1. When we start T2, it starts with a priority of 4, that is normal priority minus 1. And T3 starts with a priority of 9, that is max priority minus 1. In this case, the thread which gets executed first is T3, and then the thread which executes next is T1, as its priority is more than T2. And T2 is a thread which executes last. Synchronization. Synchronization is a process of coordinating when things occur at the same time. Let's imagine the work of Mr. Cook. He receives the order, user input, gets the recipe from the database, cooks as per the recipe, and then serves the order. Here is Mr. Tom, who wants to eat a burger. Mr. Tom orders for a burger to Mr. Cook, and Mr. Cook receives the input. Mr. Cook brought the recipe from the database, and now he started cooking. Oh, now comes Mr. Jerry, who wants to eat a sandwich. Jerry orders for a sandwich to Mr. Cook, and Mr. Cook receives the order. He gets the recipe to create a sandwich from the database. Oh, he looks confused. Anyway, he serves Mr. Tom a burger. Oh, is that a burger? Now let's see, what does he serve Mr. Jerry? Oh, maybe that's called a sandwich. Mr. Cook has realized that he has messed up both the orders by taking them at the same time. Mr. Cook has now decided to take only one order, cook and serve the order, and only then take the next order. This is exactly what synchronization does for you in Java. Here comes Mr. Cook once again with a synchronized cook method. Synchronized is a Java keyword used to declare synchronized methods, which means that only one thread can access a method at a given time. There comes the Tom thread, who wants to eat a burger. Tom thread orders for the burger. Mr. Cook is currently free. His method cook is not executing on any thread. This means that he can take the order. Mr. Cook locks the code, takes the order, gets the recipe, and starts cooking. There comes Mr. Jerry, who wants to eat a sandwich. Mr. Jerry orders for the sandwich. But Mr. Cook is not ready to take the order. He replies to Jerry saying the cook method is locked for Tom thread, and so Jerry needs to wait. Mr. Cook has now served the burger to Tom thread. This time Tom is happy. He got what he wanted. Now the Tom thread has released his lock. This means that Mr. Cook is once again free. Mr. Cook now takes the order from Jerry. He locks the code, prepares the recipe, and serves Jerry. Mr. Cook is this time happy. By using the synchronized method, Mr. Cook is now able to serve multiple clients at the same time. Every object in Java has a lock. Using synchronization enables the lock and allows only one thread to access that part of code. Synchronization can be applied to a method, as you see here in this code. Public synchronized do stuff. This implies that every statement inside do stuff is synchronized. Synchronization can also be applied to a block. Synchronized object reference. Every statement in this block is synchronized. This implies that only one thread can execute the block at a given time. Synchronized methods in subclasses use same blocks as their superclasses. Now let's look at an example. In this example, I have a class which implements the runnable interface. I have synchronized the run method of this class. This implies that only one thread can access the method run at a time. Further, I have created an object of class threadSync at line 12. And further, I have created 3 thread objects, passing the runnable object as a parameter. I am starting the threads at line 16. When you run this program, the output would look something like this. If the method run was not synchronized, then the output may differ. It could be something as you see here. This is so because when the first thread executes the run method, it starts and prints the open braces and maybe prints the name of the thread and goes to a sleep. This implies that the second thread takes the control and prints the same statements once again, and then the second thread also goes into a sleep, and further the third thread also executes the same statements, printing the open brace with the thread name as you see here in the output, and then the thread 1 comes out of the sleep process and prints the closing braces, followed by thread 2 and thread 3. Therefore, the output is something like this. If the method is synchronized, then it allows only one thread to enter into the method at a time. This means that even if thread 1 goes into a sleep because it is in a synchronized method, the other thread cannot enter the same method. And therefore, only one thread acts on the run method at a given time, and thus prints the output as you see here in this screen. You may try out this example from the Java Virtual Guru. You may also experiment by removing the synchronized keyword. Wait and notify. When a thread calls the wait method, it gets into a wait state. And when another thread calls the notify method, the thread which has earlier gone into a wait state gets notified in a queue order. When a thread calls the wait method, the thread releases the lock for the object. This means that if a thread was in a synchronized block or a synchronized method, then it releases the lock before going into a wait state. The state of the thread is said to be blocked until another thread calls notify. The thread is placed in the wait set for the object. When a thread calls the notify method, an arbitrary thread is picked from a list of threads in the wait set. The notify method moves the selected thread from the wait set to the entry set, and thus sets the state of the selected thread from blocked to runnable. In this example, we would see a waiter and a chef waiting and notifying each other. Here is the waiter thread, and this is the code that waiter calls. Here is Mr. Chef, and here is the method that he calls. Here we go with an assumption that waiter will take order only when the chef is free, and chef prepares the order only when the waiter gets the order. In order to notify each other, I am using two Boolean flags, order prepared and order taken. As you see here, if order prepared is false, the waiter waits. He waits for the chef to finish preparing the order. And similarly, the chef waits if order taken is false. On taking the order, the waiter notifies the chef thread by calling the notify method. This notifies the chef thread. And on preparing the order, chef notifies the waiter thread, once again by calling the notify method. Here is the notify method which chef calls in order to notify the waiter. Here comes a customer who orders for a burger. The waiter receives the order and notifies the chef. Chef prepares the order and notifies the waiter. Let's look at the source code for this example. In this example, I have three classes: restaurant, waiter, and chef. Class chef and waiter implement the runnable interface. Class waiter calls the method restaurant.takeOrder, and chef calls the method restaurant.prepareOrder. Now let's look at the restaurant class. The restaurant class has two Boolean members, order prepared and order taken, and two member methods, take order and prepare order. Now let's look at the code. Here is the code of take order. Take order is called by the waiter thread. The waiter first checks the value of order prepared. If order prepared is false, then he goes into a wait state. Simultaneously, the chef thread calls the prepare order. If order taken is false, then the chef thread also goes into a wait. If you have noticed, the default values of order taken is false and order prepared is true. This implies that the waiter thread does not go into a wait. Instead, directly comes to a statement after the if statement or the if condition. He prints waiter taking the order and then sets the order taken to true, order prepared to false, and then prints waiter order taken notifying chef. Simultaneously, on the other hand, the chef thread would have called the prepare order where order taken was earlier set to false, which implies that the chef thread would have gone into a wait state. Now coming back to the waiter thread, the waiter thread would call the notify method, which means that the chef thread is notified and starts working from the next statement. The chef thread now prints preparing the order, sets the values to true and false. As you see here, order prepared to true, order taken to false, and then prints chef order prepared notifying waiter, and then calls the notify method. The cycle goes on. Now let's look at the main class. In this class, I have created an object of class waiter and chef. And then we have created an object of restaurant. Set the reference of restaurant to both chef and waiter. Further, we have created two threads, waiter thread and chef thread, and then started the same. Now let's execute this program. Here is the output. The waiter prints taking the order. Waiter says, "Order taken, notify chef." Now having notified the chef, the waiter thread goes to a wait state by saying, "Waiting for chef to prepare the order." There comes chef saying, "Preparing the order." And further, chef says, "Order prepared, notifying waiter." And then chef goes into a wait state by saying, "Waiting for waiter to take the order." And once again comes the waiter saying, "Taking the order." Now this cycle goes on. Do try this program from the Java Virtual Guru. You can find the source code of this example from Java Virtual Guru. Thread joins. Imagine a case where I have two threads T1 and T2, and I want to hold T1 until T2 is done with its execution. You can achieve this by using thread joins. The join method allows one thread to wait for the completion of the other. If T1 is a thread object whose thread is currently executing, T1.join causes the current thread to pause execution until the thread T1 terminates. Join is dependent on the operating system for timing, so do not assume that join will wait exactly as long as you specify. Like sleep, join responds to an interrupt by exiting with an interrupted exception. Let's look at an example. In this example, I have two classes, myThread1 and myThread2, which extend class thread. MyThread1 has a constructor which calls the superclass constructor by passing the thread name registrar thread. And then I have the run method. The run method has a for loop which prints the thread name and the value of I. The loop also puts the thread to sleep. Class myThread2 is similar to myThread1 except for two changes. The constructor of myThread2 takes the reference of myThread1. It initializes the thread name as student thread. And in addition, it has a join method called in the run method. Coming to the main class, I am creating the objects for myThread1 and I have passed the object of myThread1 to myThread2 constructor, as you see here, and further started the two threads. Now let's run this application. Here comes the output. If you have noticed, it first executes the registrar thread. Having exited the registrar thread, it then executes the student thread. This was so because the student thread has joined the registrar thread, which implies that the student thread has to wait for the registrar thread to complete its execution. You may refer to the example from your Java Virtual Guru.